Hello there, welcome to After School. The subject is chemistry and the topic is chemical combination. We understand that in chemistry there are reactions which we ordinarily refer to as chemical changes in which new products are formed. It is important to note that for these reactions to occur, electrons are transferred or accepted from metals to non-metals. It is important to understand the configuration of different elements based on their atomic number in order to understand chemical combination. Basically, the behavior of elements, as you were taught in chemistry, is understood by the periodic table, a comprehensive knowledge of the periodic table, from where we can predict the behavior, characteristics, properties, composition, and uses of matter. So there are basically two types of chemical combination, and there are others, but we will take a look at the major two. The first one is electrovalent / ionic bonding. In this type of combination, electrons are transferred or given out by metals, and these electrons that have been given out are accepted by non-metals in the bid to attain stability, a stable electronic configuration by the participating elements. For instance, let's look at the reaction between sodium and chlorine. Sodium has atomic number 11 and the configuration is 281. It can readily lose the outer electron 1 to chlorine, which has atomic number 17 with configuration 287. When this happens, sodium becomes 28, having a stable outer configuration of 8 electrons in its outermost shell. While chlorine also, which was 7, we accept this 1 electron from sodium and add to the 7 in its outer shell, and it becomes 8, thereby attaining a stable configuration. This is what happens when sodium chloride is formed, which is a very good example of an ionic compound. That is electrovalency. There are other examples: the formation of magnesium chloride, calcium oxide, magnesium oxide, etc. For want of time, it is important to mention a few characteristics of ionic elements. They have high melting and boiling points. They have defined shape and structure. They conduct heat and electricity. So these are few properties owing to this kind of combination. The second type of combination is covalency, covalent bonding. This is slightly different from the first we have discussed because no electrons are actually transferred. Rather, electrons are shared between the participating elements. Why the sharing? Because the number of electrons in the outermost shell of these elements are plenty in number, thereby requiring higher ionization energies for them to lose electrons. Therefore, this type of elements prefer the covalent type of bonding, in which electrons are rather shared than given out. So this is what happens. Examples include the formation of hydrogen fluoride, the formation of hydrogen molecule, when two hydrogen atoms will come together to form a molecule of hydrogen. Or they have definite shapes. They are mostly gases or easily vaporized solids. That is a few of their properties. There are other types of bonding which we cannot go into details for now. They include hydrogen bonding, metallic bonding, and van der Waals forces. Then there is one major one that has to be discussed. Several scholars capture it under covalency, while others treat it differently. That has to do with coordinate or dative bonding. In this case, one of the participating elements possesses what is called a lone pair of electrons. The lone pair of electrons has to do with electrons which are not directly involved in the valency or covalency.